Welcome everyone. In this video lecture, we will solve a very good numerical in which we have to find the center frequency, lower cutoff frequency and upper cutoff frequency in a op-amp based bandpass filter. This circuit we have taken from the Boylestad book, very famous book. So the question is calculate the center frequency, lower cutoff frequency and higher cutoff frequency for the bandpass circuit shown below. So here we can see there are two op-amp based circuitry, or we can say there are two op-amp based circuit is there. Okay, the first circuit is this and another one is this, and both are cascaded. Okay, so for the simplification, I am saying this one is one op-amp and this one is second op-amp, and the output of the first op-amp, I am saying the this one is a V0 one, is the output of the first op-amp is again used as a input for the second op-amp circuit. Okay, so we have to find the overall voltage output, that is our V naught. Okay, and we have to find the value of center frequency and other lower and higher cutoff frequency. So to solve such problem, we have to generalize the question by just assuming, say, this resistance I am saying, this resistance I am saying like R1 dash. Okay, then we will solve, and I am saying this one is some feedback resistance RF dash, and I am saying this is a capacitor C1 for the op-amp 1 R1, and this one I am just noting like R2 dash RF. Okay, right, better to write RF1 and RF2. Okay, you can also write RF1 RF2. Okay, no need to write dash. Okay, or RF2 dash you can write. Okay, and this one we can write as C2 capacitor and sorry, R2 R2 resistance and C2. Okay, so in such problem, first select the first part. Suppose this one is the first part, single op-amp, and first find out the value of V01, and then we will do the operation for this with the second one. Okay, so here what observation we have observed, that means this one is basically a band pass filter circuit, band pass filter. So this the first circuit, the first op-amp 1. Okay, so op-amp 1 contributes a high pass filter. Okay, some theory that I want to high pass filter, because this one is our C and R. So there is some voltage, I am saying that V1. So this I am just noting down, C and R. Okay, and this one I am saying V1 and C and R. So the V1 is nothing but simply the V1. If we draw the gain like V1 upon Vi with frequency, it will come a second order, sorry, first order high pass filter. Okay, so op-amp 1 contributes the high pass, and one high pass and low pass is connected in cascade manner. So it is the band pass filter. So and op-amp 2, I will solve one by one. Op-amp 2 contributes a low pass filter, which is in the first order. Okay, so these are the first order. So in this one, C and R, uh, like this, sorry, R and C kind of a structure. So I'm saying this one is V2 and this one is our V01. So draw if we draw, okay, some theory, it will go like this. Sorry, it will go like this. It will go like this. The gain V2 upon V01 with frequency like this. Okay, clear? And both when we are combined, it will give the a band pass when it is cascaded. So here what we can observe, that A high pass filter, I'm writing like high pass filter, and a low pass filter are cascaded together, which forms which forms we will do it in detail, which forms a second order second order band pass filter. Okay, we will solve this one, band pass filter. So some theory, the basic theory I have already written here. Okay, clear. So now we will do the operation. So first of all, I'm just taking care of the first part, this one. Okay, so we have to, okay, I have already copied this one. So I'm just taking the first part. Okay, so I'm just erasing the second open. Okay, so this one we can say, this one is our open number one. Okay, and this one is our v naught one. And that, as we know, this already we have written r1 dash, rf1 dash, c and r. Okay, so from the figure, okay, so now we have to think about more about this one. So this one, if I am saying this voltage at any point, say v1, okay, so this circuit is somehow very similar to what? A non-inverting op amp. Means what I am doing, I am just going to simplify the circuit like this one is minus and plus, we are taking output. Okay, and I am saying this voltage is our v1, and okay, okay, and I am saying this one is R1 dash and RF1 dash, and this one is our V naught. So this configuration is nothing but simply what? Non-inverting amplifier, yes or no? And this V naught is simply 1 plus, as we know, RF1 dash upon R1 dash into V1, that we know. Yes or no? This one is a simple fundamental, okay, that the V naught value will be like this. Yes. Now we will move forward. Okay, so V1 we have to find. If we find the value of V1, we can easily find the value of V naught 1. So how to find the V1? So for this purpose, what I am doing, okay, now we are interested in this R and C, and this one is our V1 and this one is Vi. Okay, once again I am highlighting the things. If we are able to find this V1, okay, so the same thing we are going to do. Okay, okay, means this one is the circuit C and R. Okay, so now we have to find V1. Okay, so for this purpose, what we will do, the impedance of the capacitor is what? What we can write? Simply 1 by SC. Impedance 1 by SC and R. So V1 can be written as, by using the voltage division rule, V1 can be written as Vi into R upon R plus 1 by SC. Simple voltage division rule. Okay. So this can be written as VIR SC upon SCR plus 1. Okay. So, or simply we can write VI into SCR upon 1 plus SCR. Yes or no? So this V1 we have already find. The value of V1 is now known to us. Okay, this V1 and this V1. is now known to us. Yes or no? This V1. Clear? So now the value of V naught is nothing but simply this one. So what we can write, this one is V naught 1. Better to write V naught 1. Okay. V naught 1. So V naught 1 can be written as 1 plus RF1 dash R1 dash into V1. So what we will write, the value of V naught 1 is 1 plus RF1 dash upon R1 dash into V1. Okay. So V1 is what? Vi into SCR upon 1 plus SCR. Okay. Or SCR. Okay. So here we have written C1, C2. So better to write C1, R1. C1, R1. Okay. So this should be SC1. This one is C1, R1. Okay. Make it C1, R1. R1, SC1, C1, R1, R1, C1, C1, R1, C1, R1. Okay. So SC1, R1. Is it okay? Make it C1, R1. Okay. For the first op-amp. So an RF dash 1 and R1 dash is same. Okay. So it should be our cancel out. So it is 1. So the final value will be twice VI SC1 R1 upon 1 plus SC1 R1. Is it okay? The V0 one we have calculated, or in more general case, one I want to write V0 one upon Vi. Okay, is nothing but simply twice SC1 R1 upon 1 plus SC1 R1. So basically, this one is our first order high pass filter. If we plot this one is our first order first order high pass filter transfer function. First order high pass filter transfer function. Okay. Is it clear? This one means very simple calculation, but we have to know the basics. Like for the impedance, we have written 1 by SC, and then we have just apply the voltage division rule, and we have find this one. Okay, now V naught 1 is known to us. Now we have to go for the second one. Now this value is now known to us. Okay, so now we have to go for the second operation of the circuit. Okay, so for this purpose, once again, okay. So just forget about the first part. Okay, so I am okay. Okay, this one is the second part. Okay, and we have already discussed that this one is our what? V naught 1. Yes or no? This one is the V naught 1. See, this one is V naught 1, V naught 1. So I am just saying this one is our V naught 1, and this one is what? This one is our say R2 days we can write. This one can we can write RF2 dash, and this one is can be written as what? R2 C2. Okay, so now this one is V naught 1. We have find V naught 1 as a function of Vi, like twice Vi SC1 R1. Okay, so now this one is again I am saying this value is our say some voltage V2. Okay, so if we know the value of V2, V naught can be simply written as 1 plus RF2 days upon R2 days into V2. Is it okay? Simple. This one is also non-inverting operational amplifier. So now our aim is to find the value of V2. Is it okay? So for this purpose, what we will do, we will once again, I am making this very similar kind of circuit. R2 is there, and C2 is there. Okay, this one is grounded, and this one is our V naught one, and I am saying this one is our V2. Okay, so this, what, how we will solve? We will just first write the impedance for the capacitor, 1 by S, 1 by SC2. S is the complex frequency variable. Then after V2 can be written as V naught 1 into the opposite impedance, like 1 by SC2, okay, upon R2 plus 1 by SC2. So now this V2 can be written as V naught 1 upon SC2 R2. If we solve, we will get definitely this one. Okay. Then after this V2 upon V naught 1, we can write as 1 upon 1 plus SC2 R2. And if we plot the graph, this one is our first order low pass filter. First order low pass filter. So like if we plot this one, V2 upon V naught 1, the gain versus the frequency, because S is a frequency component. So this one will be the low pass filter. And okay, clear? So now V2 is known to us. V2 is simply V naught 1 SC2 R2 plus 1. So directly what we can write, V naught equals to, now one more thing, 1 plus RF2 and R2 having both having the same value. So this should be cancelled out, 1. So 1 plus, this one is nothing but simply twice V2. Yes or no? Twice V2. Because these both are same, RF2 dash and R2 dash. So twice V2. Now V2 we can write from this one. Okay. V2 will be twice V naught 1 upon 1 plus SC2 R2. Yes, clear? Now this we have written V2, okay, from this one. I'm just showing this V2 is this. Yes or no? Now we have to write the value of V naught 1. So V naught 1 is nothing but simply this. Yes, yes or no? The whole function is V. So now what we will do, can we write twice into twice VI SC1 R1 upon 1 plus SC2 R2 into 1 plus SC1 R1. So the overall function V naught equals to 4 times of Vi into SC1 R1 upon 1 plus SC1 R1, okay, into 1 plus SC2 R2. Is it okay? Simple calculation. Or in more general, we can write like, and if we solve for Vi SC1 R1 upon, if we multiply the thing, what we will get? 1 plus SC1 R1 plus SC2 R2. Simple multiplication we are doing. S square C1 C2 R1 R2. Okay. So now V naught by Vi, the function V naught by Vi, that is our band pass filter. This one is nothing but simply transfer function for the band pass filter, is what? 4 times of 4 times of SC1 R1 upon, I am writing like this, S square C1 C2 R1 R2 plus, I am taking common like C1, sorry, better to take common S C1 R1 plus C2 R2 plus C1 C2 R1 R2. So this one is a very interesting result, that the transfer function will be like this only. Okay, V naught by Vi. So now all frequency component, everything we will find, but this is the theory. that we have to know. Okay, so some more theory that I want to share. So now this one is the band pass filter. Okay, now what we will do, mm, we will do like okay, question. Now V naught by Vi, a band pass filter, and what I am writing for SC1 R1 upon, and I am taking C1 C2 R1 R2 common, then we can write like S square plus S, okay, 1 by C2 R2 plus 1 by C1 R1 plus, okay, okay, by 1 upon C1 C2 R1 R2. Okay, clear this thing. So now this is in the form of one very fundamental form of the band pass, Ks by S square plus S omega naught by Q, the quality factor, by omega naught square. Okay, this is in the this form. Okay, so this one is basically a band pass filter transfer function. Okay, now we will think about all other frequency components. So I am going for the next page. So first, so basically this one is the diagram. Okay, and wait, okay, let me go for the next page. Okay, see this one that we have find out. Okay, okay, okay. Mm, actually I have to select the value that we have find like this. Okay, is it okay this one? Now, okay, I have to write like omega naught by q plus omega naught square. Okay, so this one, this omega naught square, we can write omega naught square is nothing but simply 1 by c1 c2 r1 r2. Okay, so we can write this one 2 pi f naught whole square is 1 by c1 c2 r1 r2. So f naught value we can write directly 1 by 2 pi into a square root of 1 by c1 c2 r1 r2. Okay, because see this one is our band pass filter. Okay, so the transfer function is V naught upon Vi in magnitude will be, and as a function of frequency it is like, okay, band pass filter. So this one is our F naught. Okay, and the 3 dB point will be our 2 point that in question they have asked. This one our FOL, this point, and this one FOH. So first I am finding the value of F naught. Okay, so for F naught, this one is the formula that we have derived. Okay, so now what we will do, 1 by 2 pi, write as it is, then 1 by C1, 1 by C1. C1 value is how much? C1 already, I already told, na, this one is our C1 R1 R2 C2. Yes or no? Okay. So now C1 is 0.05 into 10 to the power minus 6. C2 0.02 into 10 to the power minus 6 into R1. R1 is 10 kilo. So 10 into 10 to the power 3 and 20 kilo 10 to the power 3. So we have to solve this one. Okay. So mm, okay, where I will solve. Okay, I am doing here. So F naught we can write as 1 by 2 pi. Now 10 to the power minus 6, 10 to the power minus 6, 10 to the power 3. So it should be 10 to the power minus 3. So just I am putting it down. Okay, 10 to the power minus 3 will become out. Okay, because 3, 3, 6. So it should be cancelled out. See, this will be cancelled out with this one with 10 to the power minus 6. So minus 3 will be outside into 10 to the power minus 3 will be outside. Then 1 upon, okay, we will solve 0.02 into 20 means 200. 20 into 10, and then if you remove this decimal, what we will get? 1 2 3 4. Okay, this 4 will be cancelled out. Then 5 into 2 10, 10 into 2 20. So 20 by 100. So if we solve, it will come root 5 upon 2 pi into 10 to the power 3. Okay, simple calculation is there, you can do very easily. Okay, so now as we know, root 5 2.23 by 2 pi into 10 to power 3. Okay, so if we do all this calculation, it will come around 0.355. Okay, into 10 to power 3 means nearly 355 hertz. Okay, so this point that we have already find the center frequency, this one point will be our 355 hertz. Okay, 355 hertz. Now we have to find the lower cutoff and higher cutoff frequency. So that can be found by using looking this circuit. Okay, this part will give the lower cutoff. Okay, so as we discussed this, from this one, the, okay, okay, so from this one, the RC circuit, this part. Okay, so from this one is our C and R. So what we will do? Okay, okay. Then the first part C and R, that we have already discussed, C1 R1, and this one is our V1 and VI. So this will give this kind of high pass filter. Yes or no? And this V1 upon VI we have already find as C1 R1. I have already done this one. Okay, 1 plus SC1 R1. And if we take the common C1 R1, C1 R1, it should be S plus 1 by C1 R1. So this one is our omega naught L. Okay, is 1 by C1 R1. So the value of 2 pi F naught L will be 1 by C1 R1. So F naught L can be written as 1 upon 2 pi C1 R1. Is it okay or no? Very simple concept is that. Okay, so what we have to do now, C1 value. What is the value of C1? 0.05. Okay, 0.05. So I'm just 0.05 into 10 to the power minus 6 into 1 upon, okay, I'm writing into 1 upon how much? Simple, 10 kilo, 10 into 10 to the power 3. Okay, so I'm doing here. So F naught L 1 by 2 pi into 1, 10 to the power minus 6 and 10 to the power 3. It should be simply our 10 to the power minus 3. Okay, into 1, 0.05 into 10. Okay, So if we remove this decimal, it is 100. So this and 5 into 2, 10. Okay, 10. So it is 1 by pi into 10 to the power 3. Then 1 by pi 0.318 into 10 to the power 3 means 318 hertz. Okay. So F naught L will be our 318 hertz. Is it okay? Now for the other one, because this part is our low high pass filter response, and this one is our low pass filter response. Okay. So next, for the low pass, again R and C is there, so we can find the, okay, I am doing here R2, C2. Okay. So similarly F naught H will be 1 by 2 pi R2 C2. Okay. So 1 upon 2 pi, and then after what we will write, C2. C2 value is how much? 0.02, I think. 0.02. Okay. So we have to write 0.02 into 10 to the minus 6, and R2 value. Okay. R2 value 20 kilo ohm. So 20 into 10 to the power 3. So can we write directly 10 to the power 3? Okay. It will be like 2 pi into 0.02 into 20. Okay. Then if we solve this one, simple calculation, I am directly writing, it will come around 397.94 hertz. 9 hertz. Okay. After solving this, it will come 397. So this value will be 397.9 hertz, like that. Okay. So like that you can find directly the lower cutoff and higher cutoff, we can find from this circuitry, because this circuit is responsible for the high pass function. Okay. This circuit is responsible for the high pass one, and this one for the low pass. Okay, low pass. So but overall function, if you have to calculate, you have to calculate like this. Okay. And then center frequency from the standard one, V naught by Vi, then we have to equate with this one. So center frequency will be this, and the lower and higher cutoff frequency can be find from the low pass and high pass. Okay. So this is the way to solve this kind of problem. So thank you for watching this video. Thank you.